Hello, sorry for this delay. I'm Igor Kulchytskyy. I work for AMI 15 years and I'm contributor to UEFI and Redfish industry standards as Abner, and I also would like to recognize our key Redfish contributor Nickel Wong from NVIDIA for his essential work on UEFI Redfish and EDK2 implementation, and also would like to say special thanks to Aman Chitrai from Qualcomm and Mike Maslyankin for their valuable support. We have this agenda. We're going to start with where Redfish was in 2019, what current Redfish firmware solution, implementation of Redfish specification, and UEFI Redfish Foundation. Also, we are going to cover Redfish client support based on UEFI Foundation, and we are going to cover advanced topics like Redfish device enablement and finish with call to action. So maybe not all of you know what Redfish is, so let me say a couple words of what is this. Redfish is a modern out-of-band management standard which was developed by DMTF to replace IPMI in more secure and extendable way. So right now it's increasingly adopted for server configuration and inventory management. So let's look back where Redfish was in 2019. On specification side, we had 3 protocols defined under UEFI umbrella. It was RESTX protocol, UEFI Redfish Discovery protocol, and UEFI Redfish JSON structure protocol. On implementation side, those protocols, was laid groundwork for integrating Redfish into firmware environment. So on implementation side, we have EDK2 project, which was like proof of concept for the developers to test those protocols and validate it before broader adoption. Let's see what we have for now. So it's this current Redfish firmware solution. As you can see, this block diagram at the bottom of the slide, it's EDK2 Redfish Foundation, which consists of several drivers, fundamental drivers. So as you can see, we have EDK Redfish Discovery driver, which is UEFI Redfish Discovery protocol implementation to support Redfish server discovery through Redfish host interface. We have UEFI REST X driver, is the network-based driver of UEFI REST protocol for communicating with Redfish service using HTTP protocol. We have UEFI REST JSON structure driver, which is used by EDK2 feature drivers to manipulate platform mode Redfish properties in C structure format and then convert them into JSON payload. We have EDK2 Redfish credential driver, which incorporates with Redfish platform credential library to acquire the Redfish credentials for Redfish server. And we have EDK2 Redfish host interface driver, which uses platform host interface library to create SMBIOS type 42 table using SMBIOS protocol. And last library we have is EDK2 content coding library, which is incorporated with Redfish lib to encode and decode JSON payload, Redfish JSON payload. We also have a couple of libraries which use open source as open source projects, like Redfish lib is a wrapper of open source project lib Redfish. It's used to initiate connection to the Redfish server, and JSON lib, it's a wrapper for open source project JSON, which is used to manipulate JSON payload. So current Redfish firmware solution we have on this slide. So it's focusing specifically on protocol implementations and their integration into EDK2 framework. So here we have formal implementation of UEFI Redfish protocols. It's UEFI Redfish discovery protocol. This protocol used to discover, from its name, to discover Redfish service, and it's middle protocol which abstracts the creation of EDK2 or UEFI RESTX protocol. So we have also UEFI RESTX protocol itself. It's designed to be used by REST clients to communicate with REST server. We have UEFI REST JSON structure protocol. It's designed to centralize REST JSON structure in and out and convert it into JSON. So those protocols, that's background of Redfish functionality in firmware environment. And next we have EDK2 specific implementations. It's EDK Redfish config handler protocol. This is centralized manager of Redfish feature drivers, which can initiate and stop those drivers by calling protocol functions init and stop. We have Redfish HTTP protocol. This protocol enables HTTP communication between feature drivers and Redfish service. So it allows drivers to issue RESTful requests while providing mechanism which to handle Redfish HTTP specific errors. And additionally, it supports request caching that enable multiple drivers to reuse the same request previously issued, and that can reduce the redundancy and improve the overall efficiency. So we have Redfish platform config protocol, and yeah, this it's just interface with platform-specific configuration settings. Using those interface, driver can get list of Redfish schemas from platform. It can get list of configure language from platform using Redfish schema and pattern, and it also allowed to set and get Redfish values. Next one is Redfish EDK2 Redfish platform config protocol. Oh, sorry, that one I covered. EDK2 Redfish credential protocol. Yeah, and this protocol is just to acquire Redfish credentials, and it also can be used to register and unregister Redfish service. So at the end, it can delete Bootstrap accounts if all registered Redfish services were unregistered. And last one is EDK2 Redfish interface driver, and this is abstract EDK2 Dixie driver to create SMBIAS 42 record through SMBIAS protocol according to device descriptor and protocol data type. So these protocols are essential for enabling Redfish-based management directly with firmware stack, and this invites us to consider whether formalizing this implementation within UEFI specification could enhance standardization and long-term support. So let's think about it. Yeah, this is our work. So server platform with BMC as a server management entity may expose USB network interface device to the platform to be used for communication. And AMI contributed this EDK2 USB NIC driver for USB communication device class. This driver supports several interfaces like ECM, NCM, and RNDs. And this EDK driver enables USB NIC device exposed by BMC to the host firmware, and this is interface between firmware and BMC. So, and then EDK2 network stack is installed on top of this USB NIC, which allows client to communicate to BMC using HTTPS. So I guess Abner can continue. So I covered the foundation, and Abner will going to talk about client side.
Right. Okay. Thank you, Igor. Okay. So based on the foundation Igor just mentioned, what is the Redfish application layers we can build on top of the foundation? So we can call that the RESTful application, right? So because we get the REST EX, we get the token from REST EX, and then we can use this token to talk to the Redfish service. You don't have to know what is the interface, transport interface. You don't have to know the underlying foundation, Redfish foundation. You just use that token to talk to the Redfish service. Okay. So what is the what is the protocol? Actually, those protocols are not defined in UEFI spec. So those are the EDK2 implementation. Currently, I forget to mention the EDK2 Redfish client repository that is under Tiano core. Okay, so in this package, there are like 4 EDK2 protocols. The config language protocol is kind of mapping to map the Redfish UI to the specific config, like HI config, HI option. All right, I can show you. There's a page, slide page, show the mapping, and ETAG protocol, which is to check if the content on the web service is the content is has changed or not changed. Okay, so we use that ETAG to see if we have to provision the resource or we have to consume the change. So this saves some boot time. Okay, and the Redfish feature protocol that is it's just like the dispatcher. Okay, so we know that Redfish define many schema, right? Like computer system, BIOS, boot order, storage, PCIe, a lot of resource, a lot of schema. I think it's over 1,000. And you can write the feature driver for each resource. And this feature driver will dispatch the resource, your driver using the URI you defined, go through the hierarchy. Yeah, because some Redfish resource is the collection. It means you can have many members. Like the Redfish service can manage more than one system, right? So you probably have 4 instances under the collection. So something like that. So the resource config protocol is also introduced to manage the collection and collection member. Yeah. So what is the usage for the Redfish client package? There are 2 major functionality. One is the config, your host firmware config. The second one is the inventory. Okay. So this is the drivers. Some of them is not upstream to open source Tiano core yet, but we do have the BIOS feature driver, Redfish feature driver to provision the BIOS configuration from HII to Redfish resource. So there is a code to do the conversion. I'll show you later. Okay, and the BIOS attribute registry, which is also auto-generated as well. So we do parse the HII database and generate the BIOS attribute registry. So BIOS attribute registry is kind of the attribute for each HI option. We can think about that way. So like the maximum value, the condition, the dependencies, and then the menu path, which can use by third-party Redfish application to represent the UI using that structure. Okay, so the BIOS attribute registry is not upstream yet, but that is if you are using HI EDK2 HII, I mean UEFI HII, then we can generate this resource, Redfish resource automatically, and for option already upstream. For option collection, computer system collection. Okay, so that is for the platform configuration management. And the second part is the inventory feature drivers. So as the Redfish provider for the host firmware, I mean, actually the host firmware knows everything, right? Not everything, but like it knows the processor, it knows how many PCI option cards on the system. It knows the hardware configuration. So actually BIOS is the host firmware is the Redfish provider for the Redfish service. It provides the system configuration to the Redfish service, right? So the below drivers are not upstream yet, but we are cleaning it up. But we, of course, we are going to upstream that. As for the AMD perspective, we are the processor supplier, right? We want to use anything from open source, not our own implementation. So we are going to reduce the proprietary implementation. So we like to use this in our reference BIOS. So we are going to upstream those code. Yeah. So this is the example for the how do we map the Redfish UI with the HII. So you can see here we use the XUEFI configuration language, right? So here we use XUEFI Redfish and the schema name and the version. So in your HI, you have the UNI file for English, for Japanese, and you can have that. You can have this for Redfish, all right? So of course, this is a one-to-one mapping to your option, and the string for this language would be like. For example, this is option 1, right? So you say the option 1 is BIOS attributes, BIOS option 1. Okay, so something like this. And then the Redfish platform config protocol is, it is the platform, I mean the host firmware solution agnostic abstract protocol. So the implementation on EDK2 is we convert the, that is like the connection between the Redfish BIOS feature driver and the HI driver. So because we have this information, so we can do the mapping, all right? So we can, I mean, get all of the HI options from database and convert that into the BIOS Redfish resource and use the Redfish foundation to provision that to Redfish service. And when system is power on, if there is some modification from auto bin to the Redfish service, we will consume that change only, because Redfish define the Redfish.settings, the property. So the latest change will be in that resource. So we grab that resource and apply that to HI options using the Redfish platform config protocol. So this is the mapping between the platform configuration and the Redfish service. So if you are not using EDK2, maybe you have to implement this protocol to do the mapping. Okay. All right, so the second part is the inventory. So why we need we have the EDK2 Redfish system topology, but this is not upstream. This is used in MD internally. But yeah, of course, we want to upstream that if industry, if community accept this. So yeah, we have so many configuration structure, right? SM BIOS device tree configuration structure for RISC-V, and now we will have the OCP UPCI. The format is not determined yet, but eventually they will have another format, right? So we know that OEM they do use the SM BIOS table like PCIe. No, there's no PCIe in SM BIOS. There's no storage, right? There is a memory and processor. Okay, so they can use that and transfer the SM BIOS table to BMC. That BMC to build up those things. But from our perspective, actually that could be easily provided by host firmware because we manage those resources, right? But the problem is we have so many configuration structure format. Then we need a way we have to introduce a protocol that can be the abstract driver. So in the BIOS and in the build time, in the post time, we can get those information from like SM BIOS, right? And we turn it into Redfish JSON format, follow the schema, right? And then provision it to the Redfish service. So there is no BMC involved. There is no proprietary implementation. So this is the consideration we have in AMD internally to use those generic way and not OEM specific implementation. So with this protocol and the platform library, you can get the SM BIOS. You can, for example, the memory information, you get that from SM BIOS. But the problem is spec always missing something, right? Like some DDR, some SPD information on DDR. That probably is not defined in SM BIOS table. So how can you do that? So that's why, okay, our implementation is, if anything we can get from SM BIOS, that's fine. If there is something we miss in SM BIOS, then we use the silicon way to get the information. But eventually we will have the unified format that is Redfish memory resource, right? And then provision that to a Redfish service. So with this protocol and the library, so it gives a lot of flexibility to not just AMD to release the CRB reference BIOS, also for the OEM, if you have some special way to get the information, then you have the chance to build up the less structure, right? So in the Redfish memory feature driver or storage driver, actually we use this protocol to gather the information from platform. Yeah, so this is the use case for the season Redfish season topology protocol. Why do we use this this protocol? Yeah. All right. So this, just I mentioned, if we have three different Redfish season topology driver for different host firmware, then maybe one consume SM BIOS, another one consume configuration structure, or device tree, or UPCI, because UPCI will be another one, another right format. And then you use the we can use the, so the Redfish feature driver for memory will be the common driver, right? And season topology will be the common driver, but you implement your own platform library. So you leverage everything on, almost everything on the open source, right? And then you can see the information on the Redfish service. And those values is usually not updatable because that is inventory, right? So you don't need to support the. I mean, we don't have to get there's no change on the Redfish service, right? So usually we don't implement the get from Redfish service and apply that on the system. We don't do that. Only configuration needs to do the sync up. And we don't have a complex structure to define the function for different component. It's very simple, but the prototype we can discuss the prototype in the community. But the prototype for this program is pretty simple. Just one version control, and then create a report or collect PCI device information or memory or CXL or something else, right? So every time you add a new API, you just increase the version number. Yeah. So we don't have a complex structure to define the differentiation for the hardware components. And the library API is also simple. You get the count for the certain hardware component, and then you get the information from the certain instance, and then build up the structure. And then in the Redfish feature driver, we'll convert that structure into the Redfish resource. All right, so next one is the RDE. So that is another use case we would like to connect this with UEFI. So besides the Redfish host interface is what we just mentioned, that is part of the Redfish host interface. It means it's between the host and the firmware. But host and BMC, right? So RDE is no host firmware involved. So BMC can talk to the PCIe card if the PCIe is RDE capable device. So you can get the Redfish resource, Redfish schema, dictionary, those RDE meta files from the PCI option card and represent it on the Redfish service, right? So when user use HTTP page to change the config, then BMC will convert that into RDE PLDM. That is PLDM type 6. So BMC convert that HTTP into PLDM type 6 request and send it back, send it to the RDE entity. Okay, so the entire flow is follow the industry standard like MCTP protocol, PLDM protocol, and then PLDM type 6. Yeah, so this is another way to configure the PCIe without BIOS, without host firmware support, right? So some option card, they do have the HRI in their option room, but some maybe not. So, but now most of the OEM, they would like to let their customer to configure the option card during post. So it means the option card vendor, they have to provide RDE and also provide the HRI in the option. Right. So, okay. So for the RDE, there is a JSON format as the human readable configuration representation, and the binary encoded JSON, which is the value for the config, but that is not in text base. That is in binary encoded JSON. Okay. So it's much smaller, and the integer size will be it's not fixed. Like if your value is more than 1 byte, then there are 2 bytes for that. If your value is under 1 byte, under 255, then you just use 1 byte, something like that. Okay, and we think that this format of these two formats can map to the UPCI, because UPCI has the same concept, right? So instead to introduce another format for the UPCI, then what can we leverage from the existing industry standard? So that is what we are thinking, and then how do we connect this to the UEFI, right? So currently, AMD, the next generation SoC, that is the RDE capable SoC. It means our silicon configuration could be configured using Redfish service. and no matter system is in power off or power on, right? And then when the system is power on, we'll consume those settings. You don't have to reboot. It means there's an example someone asked me yesterday. So they want to enable our debug log for our microprocessor, but it has to put up power on the system, go to setup menu, and change it to enable, and then reboot it again, right? But with RDE, because there is no host firmware involved, so it means BMC can talk to the RDE device on processor. If the DC is applied, of course you have to turn on your system. So we can consume that settings immediately. So once, for example, if you enable the microprocessor log, debug log, when you power on system, you can immediately see the change. So this is the kind of the host firmware solution agnostic, right? So because you don't need the UI in your firmware, right? No matter EDK2, Tiano Core, or any firmware solution, right? And it doesn't require your system, the RIP for your system. So same, the PCI option card has the same capability, right? So can we connect, I mean, for the OCP, UPCI, the format for these two structure, can we leverage the RDE, like we use the we use the binary JSON, binary encoded JSON as the machine readable representation, and use JSON plain text JSON format as the human readable presentation. Of course, we need to provide some other stuff like the attribute for the configuration, like maximum value or dependencies. But same thing is defined in the VFR, but on the Redfish side, there is a BIOS attribute registry. It means we can leverage that attribute registry to describe the attributes for the config. Okay, and how about on the host side? If we currently have the manageability, right, implemented on Tiano Core, so it means host can talk to SOC, talk to option card using follow the RD spec, and then we get those configuration and dictionary and those meta files, and then we build up the UI for that. So it means, or we convert that to VFR, right? Something, right? So it means the binaries, the configuration, and the representation is carried by the device, not the host firmware. So this is something we would like to consider to leverage the existing spec for the UPCI, or to unify, to reduce some. I consider that is redundant effort, right? So not quite ecosystem, because you have to implement different implementation for the different host firmware, right? Okay, so I think this is call for action. So I think we have to review what protocols currently is named as EDK2. What protocol is valuable to become part of UEFI spec. Right, so this will be something we can review with IBB, and also the further have the further discussion. Like I mentioned, how to integrate UPCI to UEFI, and how do we convert the UPCI format into HII format, or something. So there's one thing I forget to mention. So, but that is about UPCI. I think long time ago, there is a link here, the XUEFI keyword mapping. So we have that page because we would like to increase the interoperability between servers. So there are some common defined for the boot, for the silicon, for the processor. So once we have the definition for the UPCI, maybe we have to update this as well. So or we update this and then integrate that to UPCI, so we can have these two spec inconsistent, right? All right, so that's all for me and Igor. Any questions? Yeah.
Looks like there's one question.
Could you go back to slide 15?
15?
Yeah.
I'm so scared. Where are you going to ask?
Okay. So if the Redfish is populated from the HII,
Right.
how do you handle situations where in the VFR it has suppress if?
Oh, yeah. So we have an option, actually. So yeah, actually, the logic is same as the VFR code. I mean, the HII code on the MDE package.
So it just wouldn't show up
Yeah.
in the red. Okay,
Actually, it doesn't show up on the Redfish side, Redfish service,
good.
right? So there is an example. So we still have time? No? Oh. So no, that's ridiculous because AMD, our HI option, do you know how many? 3,000.
Yeah.
So, but with that is without the suppressive. With suppressive, there's only 1,000. Bad.
Well, yes, but how about if there's just items that you want to show up with BIOS setup, but you don't want them to show up in
But you have
Redfish?
But you have. Oh, you mean even there is no? Yeah. So yeah. So you're saying even you don't have suppressive, but you don't want to see that.
Right.
So you don't have that.
You don't want to.
with NIFI file.
Yeah.
Yeah. So like you don't want to see the number 3 option.
Yeah.
Just remove number 3. So
No. But I want it to show up
you want to show up.
in BIOS setup.
Language, yeah, then it will not go to Redfish.
Oh, so okay. So yeah. So again, you
Say it again. What?
Yeah, no, I mean, so your question is, you in your PFR code is
Yeah.
suppressive or is not suppressive?
No.
We want to show it in
So it's
setup, but
supported
not
in
in Redfish.
supported in BIOS, but not supported in
Yes.
Redfish.
So that's what language is.
Yeah, you just don't provide this language.
You don't put it in the schema.
Right. So because we are trying to find it, we use the schema name and version to match
Okay.
this
So you thought
So
it.
if you don't have language there,
Yes.
yeah.
Only attributes which
Yeah.
marked with this language will go to Redfish.
Yeah. So because AMD, so there is a interesting.
You're going to pick on AMD. That's good.
Yeah. It's interesting because NVIDIA also use this, right? But they only have like under, is there any NVIDIA guys here? So they only use under one, I think it's like thousands options, right? Yeah, I told him we have 3,000. He said, what? You have 3,000, yeah. So you know how much time it takes to provision 3,000 options?
Sure.
So when I
And that's
start,
on boot, right?
yeah, no, but you know what's the problem? It's over 40 minutes.
14 what?
40 minutes. Yeah, but I know that's 40 because I have no patience to wait there. So when I see it's 40, I just left. But when I come back, it puts.
That's good.
All right, so you know the problem is where? Because we have to do the mapping. We have to search the HI's database.
Yeah.
And the string compare is terrible. It takes 40 minutes. So we do have the optimization in our open source solution on EDK2. It's only 4 seconds.
Oh,
4 seconds.
but still, that 4 seconds is a lot.
Right. So and for the provision time on over the USB NIC, I think it's like if for 3,000 options, I think it's like 10 seconds.
Oh.
Yeah. I don't measure that, but this is my feeling when I put the system.
Yeah. I mean, we try to get to 3 seconds, so
You turn it to 3 seconds?
we'd like to.
Oh, you like to with 3,000 options?
No.
Oh, okay.
0.
All right. Yeah. Okay. Any questions?
Thanks. Hi. This looks really good for things like third-party NICs, as you pointed out, where you can configure this. But I'm thinking that actually, UEFI has been around for 8 years or something, probably longer. The problem with NICs has always been that you have weird configuration options that don't exist on other NICs. Like, for example, you have 10 gig mode or 40 gig mode. It's a boot time option. It exists on this NIC, no other NICs. the driver writer will write it into the HII forms, and being able to add a Redfish path that will be taken by the configuration manager and then shown to the user over Redfish, that's really good. But if we're doing that, why not just take all of the VFR forms, which already have a hierarchy and a structure and the names and GUIDs and all of that, just process it in the configuration manager and then without mapping. Yeah, without mapping it onto the Redfish schema, because sometimes we don't quite have the same things in the schema that we want to expose to the user. Why not just export it to the user and let the user try and understand what these options mean? Because it's the same as if they were looking at the BIOS screen.
Yeah, I think the reason would be we use Redfish for, I could be over 10 years, right? So that is a way to provide a modern configuration method, or also for the out-of-band users, right, using that RESTful API. So that is something we would like to align with. So your suggestion, I think we never considered. We just want to have something that to leverage the existing industry standard and the tool chain, the mature tool chain already there. Yeah.
Okay. Yeah. Fair enough.
Okay. Thank you.
All right. Thank you. Thank you so much.
All right.